In this video, I'll discuss UML class model considerations when analyzing the conversion process, and then the steps in building the resulting database. Now, as you might recall from our work with previous business processes, the UML class model helps us determine the information needs we have for the process, which in turn guides our development of the resulting AIS database. Much work should go into developing the UML class model because, as we know, converting that class model to a database is a fairly mechanical process. And as before, you should continue using the REA model, that is, resources, events, and agents, to organize your UML class model. So here's an example of a conversion process for a small business. Note that the bill of materials links one finished good to the raw materials that are used to create it. Therefore, we've got two associations between bill of materials and inventory. One for the finished good, one for the raw materials that make up that finished good. If you recall the conversion activities from your previous coursework, that bill of materials is more or less a list of ingredients, if you will, a list of parts, a list of components that go in to the final finished good. Now, companies may have alternate bills of material for the same finished good to account for availability of different materials. And in this case, you can go back to thinking of a recipe here where you may be able to substitute one ingredient for another. If you happen to be out of one spice, you can substitute another spice. So that's a good example where you may have multiple bills of material for the same finished good. Now note that materials and production operations accumulate work in progress inventory information and also update finished goods inventory after production is complete. This UML model is a good starting point for conversion, but there may be other considerations. Do you want a production status type image for the production operations? What about machinery or equipment used in the conversion process? Those might require another resource class. If you're using machinery or equipment, and you can even think of a bakery with its ovens, you need to be able to schedule and track what's available and what's being used. And then also in a lot of manufacturing environments, the machines can record their activities and report it for costing purposes. The key takeaway here is that conversion is the process that will likely be most different from organization to organization. As with revenue and expenditure cycles, it's good to have a basic template in your mind with the understanding that the end process models may be dramatically different from that internal template. From this point, we can add the remaining details for our class model. First, we would identify the primary key attribute for each class. Next, we can identify foreign key attributes, matching them to the name of the primary key in the related class. Then, based on our information needs for the process, we can determine which additional attributes we need to collect for each class. And at this point, we're ready to start building the database. Let's discuss that resulting database. So far, we have created the BPM and activity diagram. We have created the UML class model for our conversion process. Now we're ready to build that database indicated by the UML class diagram. So the first thing we can think about is which tables we'll need. And that REA diagram gives us a good starting point. We'll need a table for each resource, for each event, and for each agent class. We will also need a table for each type image class. And then we'll analyze the associations in our class model, and wherever we see a many-to-many association, we know we'll also need another table, a linking table. So now we have these tables and we can start defining them in our database. You may have some experience with Access. You can think of what you would do in Access here, but the same concept is true for any database, whether it be a giant corporate database or any other relational database tool. So we've got our tables. We'll define which columns need to go in each table. And the columns are the equivalent of fields in a data file. So which columns do we need in our table? What are our keys going to be? And in particular, as we define the tables, what's that primary key going to be? What data types are we going to require for each column? How are we going to format the data in that column? And you can think of things like phone numbers, where they format it for you as you type it in, or postal codes, tax IDs, social security numbers, things like that, where the dashes automatically get inserted for you. So what kind of formatting or input masks do we want? Do we have a list or a range of allowable values for that column? We can take a look at the associations and turn those into relationships in our database. And here we start considering the foreign keys that we have in each table and link them to the appropriate primary keys. And we'll also consider referential integrity for our relationships to make sure that we maintain integrity over the data in the database. And that's basically it. Once we've gotten through all that, we've got the structure of the database. And at that point, it's just a matter of starting to put data into the database. So that's it for our discussion of the UML class model and database for the conversion process. I hope you found it useful.